Density. A very important concept and a property that we use all the time in chemistry. Just remember that every substance has a specific density. And here's a nice visual for density. What is density? Well, imagine you have two cubes here, and imagine you have particles in there or objects. Notice how this would be low density because you have less that occupy that same volume, that same amount of space versus this one right here. You can think of it as a classroom as well. If I have a classroom that has 32 students in it versus a classroom that has 16 students, you know that, and if it's the same size, you know that this one is twice as dense. That's what density is. So let's look at the definition. So it says it's the mass of a substance per unit volume. It's how much material in a given amount of space. And here's the equation. Might have seen this before. D is equal to M over V. Mass is measured in grams. Volume is measured in mils or cubic centimeters. A cubic centimeter is the same as a mil. So it comes out to be generally, if it's for liquid, it comes out to be grams per mils or grams per cubic centimeters. Now, can it be expressed in another way, like kilograms per cubic meters? Absolutely, it can. For large amounts, it can be done that way if it's in the SI unit. But in this case, we actually are going to use it here for chemistry because, again, this is a simple way of measuring it, calculating it by measuring the mass and the volume. Now, if you want to calculate for density, all you have to do is take mass divided by volume. If you want to solve for volume, you have to actually do some mathematical manipulations here. But there's a quick way of doing it because it's generally we need to calculate it really quick. And not only this, we sometimes have to work with cumulative problems where this calculation is the last part. So again, dimensional analysis plays a role. You need to remember that mass is on the top, density and volume are on the bottom. So if you want to calculate for, let's say, density, then just cover the density and you say it's mass over volume. If you want to solve for volume, it's going to be mass over density. If you want to solve for mass, then it would be density times the volume because, again, they are not in a fraction anymore. So that's what you need to use. Now, every substance has a distinct density value. If you notice here, you have metals and you have liquids. Iron, 7.8 grams per cubic centimeters. Zinc is 7.1. Magnesium, aluminum. Water is about 1 gram per mil. Notice how for liquids we use mils, and for solids we use cubic centimeters. Hexane, dichloromethane, ethanol, and alcohol, they are less dense, for example, than water, but dichloromethane is more dense. So let's look at a simple problem here. Start with very simple problem. It says 100 grams of mercury. Right away, you know this is the mass. Grams is the unit for mass. Occupies 7.36 mils of space. You know right away that that's the volume. What is the density of mercury? So it's going to be D equals M over V. Take the grams, 100. And we divide by 7.36 mils for the volume. Now, before you go on and continue, remember significant figures have to be used all the time. So can you determine how many significant figures are in the first number? So in the mass, you have 4. All of those zeros count. You have a decimal point. And in the volume, you have 3 significant figures. All of those are non-zero digits. So again, keep that in mind all the time. So if we take 100, divide by 7.36, we get 13 point, let's say 586. We'll stop there. Let's round to 3 significant figures. Remember, that's a rule for division, multiplication. So this is our first, second, third significant figure. What comes after this 5 is an 8. So that means we have to increase the number to a 6, increase that 5 to a 6. So it's going to become 13.6 grams per mil. What does that mean conceptually? If water had a 1 gram per mil density, then mercury is almost 14 times as dense. You have 14 times the amount of particles, let's say, of mercury than water, and the same amount of space. And if you've ever seen mercury, it's the only liquid metal. It's very, very heavy. Again, it's very dense. So that's the idea.